All right, here we go. We're going to talk about prove parallel lines today, section 3.3. Do not panic. Don't freak out. It's not actually a proof what we're talking about. But as some of you guys have started to figure out, that proofs are actually not too bad once you get that vocabulary down. And again, the vocabulary is consistent of the properties, the postulates, the theorems, among other things. And again, I can't stress vocabulary, vocabulary, vocabulary. Okay? So let's go ahead and just jump right in. In 3.2, we were in 3.1, we were introduced to what alternate interior angles are, alternate exterior angles are, consecutive angles, and such. And then 3.2, we actually applied them, and we basically added some theorems that we learned that basically said that if you have a transversal cutting through two parallel, keyword parallel lines, then your alternate interior angles are congruent, your alternate exterior angles are congruent, your consecutive angles are equal to 180 degrees, your same side exterior angles are supplementary, and then your alternate exterior angles or your corresponding angles are congruent. So we talked about the parallel lines with the transversals being creating those angles congruency or those angles supplementary characteristics. But now what we're going to do is we're going to do the converse. We're going to switch that around. So instead of proving that those angles are congruent because of the parallel lines, now we're going to prove that the lines are parallel because of the congruency. Okay? So here's our parallel line angles converse. Okay? If an alternate interior angle is congruent, or if they're congruent, then the lines are parallel. Okay? Before we learned that because the lines were parallel, alternate interior angles are congruent. Now we're saying the converse of that if you have alternate interior angles that are congruent, then you have two lines that are parallel. So if you look here, we have angle 2 equaling 59 degrees, angle 3 equaling 59 degrees, and since angle 2 and angle 3 are congruent, and they are alternate interior, because look here, here's your one line this way. Again, if you extend that line out, you'll see it. Here's your other line this way. This essentially creates your parallel lines. And then here is your transversal right here. Since these are inside the parallel lines, those are the interior angles, and one is on the left and one is on the right, so that's your alternate interior angles. And so since these are the same, then line AB is parallel to line CD, or DC. And that little symbol right here, the two lines that look kind of like mini parallel lines, that's what that represents. And no matter what I do here, you'll see that these are congruent. Because these are congruent, these lines are parallel. Okay? So again, all we did was we took what we learned in 3.2 and we flipped it around. That we used the converse of it. So we proved the lines parallel now versus proving that the angles are congruent. Okay, now if we're looking at our alternate exterior angles being congruent, okay, this is the converse again. Now if we have alternate exterior angles being congruent, then the lines are parallel. So here's another drawing. Okay, and now we're looking at angle 1 and angle 2. If you notice here, you have your line FG and your line HI. Those are the parallel lines with your transversal cutting those lines right there. The JE or the JF, or the IJ line, if you want to call it, that's the transversal cutting it. And so now angle 1 is on the outside of the parallel lines, just like angle 2 is on the outside of the parallel lines. And since angle 1 is congruent to angle 2, because these are alternate exterior angles, that must mean that these two lines are parallel. Let's take a look. So now I have line FG is parallel to HI. If you understood 3.2, then 3.3 is a snap. Okay? What about the corresponding angles postulate? Okay? Let's take a look here again. Here's our Here's two lines that are presumably parallel. If these two lines are parallel, this would be our transversal. Not that, excuse me. We can prove that these are parallel if angle PQR, that's this angle right here, is congruent to angle QST, it's this angle right here. Because these are corresponding angles. They're on the same side of the transversal and the same spot on their line. If they're congruent, then the lines are parallel. And you can see that PQR is 51.7 and QST is 51.7, so they are parallel. So they must be congruent. I'm sorry, parallel, excuse me. So TS, so line TS is parallel to line QR. Okay, next. How about our consecutive angles supplementary theorem? Again, we're just talking about the converse here. It's basically asking us to say, hey, well, let's take a look at this. Now we have two sets of parallel lines, or presumably they're parallel lines. We're going to prove them right now. So here's a parallel line, and here's a parallel line. Then over here, you think that these two might be parallel. Here's one, and here's one. So here's the deal. If these two lines are parallel, then you have this being a transversal, or this is a transversal. Okay? If these two lines are parallel, then you have this being a transversal, or this being a transversal. Now, when you have to really look at your question to make sure you're looking at it right, to know which one you're talking about. Now, if I'm talking about consecutive angles, okay, I'm talking about, and we also call them consecutive interior angles, okay, I need two angles that are in between parallel lines that are consecutive, one right after another. Now, here's our parallel lines, and here's one right after another. Over here, I have two parallel lines, but if this is my transversal, these are interior angles, and these are consecutive this way as well. So both ways, for this particular problem, these are consecutive angles. Now, based on the consecutive angles postulate that we learned in 3.2, we know that consecutive angles should be supplementary, or supplementary, which means that they equal 180 degrees. So if you do the math, angle 1 plus angle 2 equals 180 degrees. If that's the case, then your lines are parallel. So 63.3 and 116.7 are definitely equal to 180 degrees. So lines UV, this one here, and WX are parallel. Okay? All right. Now let's take a look at this. If A is parallel to B and B is parallel to C, so A is parallel to B and B is parallel to C, then what? Can you say that A is parallel to C? You absolutely can. Why? And if you said law of syllogism, you'd be almost right, but we don't really use the law of syllogisms. We are more using the transitive property. Remember, if A is B and B is C, then A must also be C. There's no addition involved here, so there's no substitution. This is just straight. Because B's are the common, we take those out and put A in there. Okay, and that's pretty much it for this unit. I do want to touch on a couple things before you hit pause or close out this video. One, please make sure that you are memorizing these vocabularies because these are going to continue to build on each other. You're going to need to know these throughout this whole year in geometry. Okay, it's very important that if you didn't catch it in 3.2 or you didn't catch it in chapter 2, the different theorems and postulates, that you know them now or go back and study those. Okay, you cannot accept a low grade because you did not go back and study your vocabulary. The biggest problem I'm seeing with most students is they don't know the theorems, the postulates. They don't know the vocabulary. If that means you got to bust out some note cards, bust out some note cards so that you are fully prepared for this. And as always, if you have any questions or you need any help, I'm always available in the morning except for Fridays, from tutoring 8:25 to 8:55, or you come see me in PASS Monday through Thursday, 4 to 5 in room 158 or lab 158. All right, you guys have a good evening. I'll see you tomorrow.